Welcome to another podcast. This episode we're going to be taking a look at binomial coefficients, which a lot of people will refer to this as combination problems, but I wanted to start off with a video where I actually show you where binomial coefficients get their name. And they basically come from looking at factorizations of binomials. So as just sort of a starting question for us to consider here, let's think about the problem of factoring something of the form a plus b cubed. So if I was to ask you, how do we factor a plus b cubed, then there's a couple of different ways that we could go about doing this. I want you to think of it primarily, though, as being a three-way product, or a product of three factors, a plus b times a plus b times a plus b. And with that, I want us to kind of form a table here. And what this table is going to look at is basically which factor do we choose from among them, and then we're going to look at the result. So what is the result of that? We're going to look at it this way. So I'm going to start with, for example, from the factor a plus b, let's suppose that we chose all a's. So if you were multiplying across, basically what you do when you factor is you choose one of the factors from each of them, or one of the components from each of them, and then multiply all across. So if we chose all of the a's to multiply with, the result of that would be a cubed. What if I then chose a, b, the result of that would be a squared b. If I chose a, b, a, the result of that would also be a squared b. What if I chose a, b, b? Then the result of that would be a, b squared. And we would keep going until we've listed every possibility. So let me go ahead and quickly finish this out. We're going to list every possibility now. How many possibilities should there be, by the way? So how many rows to this table should we have? Well, if you consider that, think about back to counting rule, we have two choices for each factor. Then there are going to be 2 times 2 times 2, or 8 possible results that we get from choosing different factors. So we have 4 of those possible results. Let's just go ahead and finish it out now. With BAA, this would be a squared b. And then we have, let's say, BAB. So this would be ab squared. And then we have BBA. So this would be another ab squared, and then all b's. So these are the possible arrangements of products that we get by choosing either a or a b to multiply other parts by. The result is that all of these have to happen. All of these matchings have to occur in order for us to completely factor a plus b cubed. And so the result of this is we end up with an addition of this. And if you look, you have 1a cubed, you have 1, 2, 3 a squared b's, you have 3 ab squareds, and you have the 1 b cubed. And so the result of a plus b cubed is this factorization, a cubed plus 3a squared b plus 3ab squared plus b cubed, and the result of that is this sort of choosing, like we did in the columns, choosing all possible values sort of that we're matching up here from each of the possible factors. So the question is, at this point, how do we generalize this? And when I say generalize, I mean, what if I asked you about a plus b to an arbitrary integer power n? We're going to stick with positive integer powers for now, but what if I asked you a plus b to the n? Then a plus b to the n is just a plus b times itself n times. There's a total of n factors here. And correspondingly, we would have something that probably looks a lot like this formula. We would have an a to the n if you chose a, and you would have a b to the n if you chose b all n times. But in between those, we would have things that would look like this. We would have an a to the n minus k, let's say, and a b to the k, because the very least is you have to have you have to have n total choices. So if I choose b k times, then that leaves n minus k times that I chose a. The question is, what is the coefficient of that? So that's what I want to ask now. What is the coefficient of a to the n minus k, b to the k in this expansion? And if you've gone through the Calculus 2 course, you talked about something called the binomial theorem. You're probably familiar with the answer to that question. Let's just rephrase that question in a different way. Instead of asking what is the coefficient, let's talk about what that coefficient does. So the coefficient here, whatever we're going to call it here in a second, basically this coefficient chooses from among n factors how many ways there are to choose the factor b k times. So the name that we give to this is the coefficient in k, which you should read as n choose k, because literally that's what we're doing here. We have n total factors and we're choosing k of them that would be represented with b's. So this is called a combination. In fact, this would be called a k combination. Now, in general, when we think of n choose k, there are several different notations that are used. The primary notation is the one that I'm exhibiting here, which is sort of the binomial coefficient notation. Another popular notation is the C in K notation, just to designate that it's a combination. And then finally, you'll also see this notation as well. But all of them stand for the same thing, and they all count the number of subsets of size k from a group of size n. This is what they're counting. So in this standpoint, it's basically looking at how many subsets of the set of choices of factors here have KBs chosen from them. So it's basically looking at all subsets of size k from a group of size n, or if you want to think of it, you could think of it the way the coefficient works, and that is simply that it's choosing from among n total options how many of them occur k times. This combination has two things that are expressly a part of it. The first is that, we'll talk about those in a later video, but basically n choose k essentially is going to pick the number of subsets. That's how I want you to think of it. Count the number of subsets of size k from a group of size n. Now, as just sort of a small example of this, if I was to extend this a little bit further, we talked about generalizing it a plus b to the n, and now that I know the coefficients here and I know what the general term looks like, I can say that the expansion of a plus b to the n is the sum of k going from 0 to n, where all the coefficients are n choose k's, and you have a to the n minus k, b to the k is the general term. So the way that this would look if you just wrote it out, just wrote out the first couple of terms, would be n choose 0, a to the n, b to the 0, plus n choose 1, a to the n minus 1, b to the 1, plus, and then it would keep going down, and it would terminate with n choose n, b to the n. times a to the 0 here. This formula is one of the more celebrated formulas in mathematics, and it's called the binomial formula or the binomial theorem. So you talk about the binomial theorem in calculus when we look at the function a plus b to the x, but this is discrete, not calculus, so our powers can only range over a discrete subset. In particular, that discrete subset for now is the positive integers. Of course, we could include n equal to 0 if we wanted to, but there's really not much to say when n is 0. The answer is just 1. So the question is, can we do this for just an arbitrary example here? So let me go ahead and create some space here. And we're going to try an arbitrary example with this just to see how we do. Alright, so the example is, let's find the expansion of 3x minus 2y to the 4th using the binomial theorem. Then I think of this as being 3x plus a negative 2y to the 4th, so that in the application of this formula, a is 3x, b is negative 2y, and n is 4. Now, rather than use the summation notation, I'm just going to write out the individual terms. So starting with, the answer here is 4 choose 0. I'm going to have 3x appear 4 times, and I'm going to choose the negative 2y to appear 0 times. Plus 4 choose 1. We're going to split it up where I choose the 3x 3 times, and I choose the negative 2y 1 time. And then 4 choose 2. 3x squared, negative 2y squared. 4 choose 3. 3x to the 4th, and negative 2y, or excuse me, 3x cubed, and negative 2y, because it's got to add up to 4, right? 4 and 0, so 3 and, this would be, 1 and 3. So 3x would be chosen once, and negative 2y would be chosen 3. And then finally, you would have 4 choose 4, where 3x is not chosen at all, and negative 2y is chosen 4 times. The difficulty at this point, though, is understanding what the binomial coefficients equate to. So for example, if I look at 4 choose 0, that's how many ways there to choose nothing from a group of 4. Well, that one's pretty easy to do in our heads. There's one way to do that. You just don't choose. So 4 choose 0 is 1. 3x to the 4th is 3 to the 4th, x to the 4th. Then over here, 4 choose 1 is, if you've got 4 items, how many ways are there to choose one of them? Well, that one's pretty easy to do in our head as well. That's just 4. Then you have 3x cubed, so that's 3 cubed times x cubed times negative 2y. And then you've got 4 choose 2. Now, you're going to have to trust me here. 4 choose 2, for the purposes of our problem, is going to be 6. And that's the one we're going to need to figure out how to do. And then it's got 3x squared is 3 squared times x squared. And then minus 2y squared is 4y squared. And then 4 choose 3. 4 choose 3 is the same as 4 choose 1 if you think about it, because 4 choose 3 is how many ways are there to choose 3 people from a group of 4 or choose 3 objects from a group of 4. That's the same as choosing which one object to leave out. So 4 choose 1 was 4. 4 choose 3 is also going to be 4. And so 3 to the x is 3x, and negative 2y cubed is, negative 2 cubed is going to be negative 8 y cubed. And then 4 choose 4, you've got 4 objects. How many ways are there to choose all 4? There's only one way to do that. Times, you've got negative 2 to the 4th, which is 16, and then y to the 4th. So we're able to string everything out, and if we sort of combine algebraically the things that are left, we're able to easily enough go ahead and calculate this. And you should check all the calculations here just to make sure that they are sound. But the thing is, and the problem is, how would we do this in general, being able to find those coefficients for much larger values or for just general values? In other words, what I'm asking at this point is, how do we define the value in choose K? And that's sort of a difficult thing to talk about in general, but if you allow me here, I want to think about it in terms of something we've already encountered this semester, and that's the falling factorial. So if I ask you what is the formula for falling factorial K, then you should know this from earlier. Falling factorial K is n factorial divided by n minus k factorial. And remember what the falling factorial notation does is it calculates n objects where I choose k of those objects and I order them k at a time. Meaning I have n objects, I need to choose k of them, then I'm going to take the k objects and line them up. Well, if you focus on what that's saying, then it's basically saying that you're going to take the n objects and choose k, so you're going to do a combination, an n choose k first, and then you're going to impose an ordering. And if you're ordering k factorial things, then basically what you're telling me here is this falling factorial notation is n choose k times k factorial. Because you are choosing the objects first, right? You're choosing the k objects, that's what this part does. And then you are ordering the k objects, and that's what this part does. So if we use this to come up with a formula, then we know that n choose k is n factorial over n minus k factorial. That should be equal to n choose k times k factorial, which means that if we just focus on this a little bit here, then what we have, and I'll clear some space for this right here, I guess. What we have at this point is n choose k is equal to, you can see here, n choose k is equal to n factorial over n minus k factorial times, you've got this k factorial here, I need to divide it over, so divided by k factorial. This is another really important formula that you should remember. This is the combination formula. It tells us how to calculate these binomial coefficients. And just to test this formula out, we got through saying just a bit ago, you're going to have to trust me that 4 choose 2 is 6. This is where we use that. So let's test that. 4 choose 2, according to the formula, is 4 factorial over 4 minus 2 factorial times 2 factorial, which is 4 factorial over 2 factorial, 2 factorial. So the way that factorials work, you know, this is 4 times 3 times 2 times 1, and this is 4 here. 2 factorial is 2, so 2 times 2 is 4. Canceling the 4's, 3 times 2 times 1 is 6. And so 4 choose 2 is indeed 6. So two major things to come out of this video, if you're going back and reviewing later. The first thing is binomial theorem is where we get the definition of the binomial coefficients. And so understanding where they come from and what they represent. And then the second thing is how do we calculate them. So this has been a rather long video. Thanks for sticking with me. I had several things to do in this video, but this is sort of an introduction to what the binomial coefficients are and what they count. Thank you for watching.